Hi everyone, in this video we're looking at a guide to PSMTs. Now I've already got started technical difficulties, but we are looking generally at that process of designing your garden bed. So if we have a look here, there's a 4-step process: formulate, solve, evaluate, verify and communicate that you need to use when doing a PSMT. So a PSMT is a problem solving and modeling task. In this case it's your garden design, and that's your big questions, like what is the best garden you can design. So think about it in relation to what is that question asking you to do. That's it there. And you need to, before you get started, you need to create a plan, and that's what the word formulate means. It means to create something, or to create a plan or to devise a plan. So your plan is going to be like your recipe. Now your recipe requires a couple of things. It requires ingredients, so your observations, things that you already know, like what important information is given to solve the problem. And assumptions would be things like when you know that the recipe calls for a cup of something, that you are assuming that the cup that you have is accurate. So it's like these things are expected that you understand what it is. So essentially, things that you need to know is observation is what's important, and that it could be used to solve the problem. So it's what I keep always telling you with you do a problem solving task is, what's the question asking you to do? How are you going to solve? What's the important information that's going to help you to solve it, and how are you going to solve it? So those 3 questions are here in your formulate section. Once you've got your observations, so the stuff that's important, assumptions, they're the things that you want to make up, or you have to assume for the mathematics to work. So things like, if you have a question where you go, it costs, Mary $30 to fill up a tank of 50 litre tank of fuel, and you say how much, how far does Mary travel on that tank? With that type of stuff, you need to know that you're going to make an assumption that Mary will use the whole tank, even though generally in real life we don't empty a whole tank. And when we're driving, we don't go to bone dry, because you can't do that to your car. So an assumption for the mathematics to work means that it has to be completely emptied. So that's essentially what we're looking at here, but on a assignment scale. We'll look more specifically in another video when we do your consideration section. And your plan is like a recipe. So how are you going to solve this problem? So step out some ideas and processes. Once you've got these things, you're going to then do a solution, or developing a solution. So this is where you do the mathematics. Things you include in your solution is your calculations, diagram, maps, drawings, and explaining your process. So you might be like, the first thing I did was determine the outer limits of my usable garden space. Then I plotted garden beds in. Then I'm going to put in pathways, and then add additional features to make my garden user-friendly. Once you've done that, then you evaluate and verify. So with the evaluate and verify, so you actually proceed to that once you believe that your problem is solved, or you have answered your question. Now, sometimes we've noticed that, and I've tried to encourage you, everyone, is that with solving a problem, it might not always be a clear cut like A to B. You might have to go A, then C, oh, that didn't work. Go back to the drawing board, A to D, go back, A, D, E, then B, and then you find that you're at your solution. So there's never a real linear, a straightaway progression. For some, yes, not all the time though. So evaluating, remember the word evaluate means to find the value of something. And in this case, we're going to be finding the values in terms of pros, so strengths, and cons, or limitations, for your solution. So how effectively did you solve the problem? Is your answer reasonable? Is there another way to check your work? So check and verify. that's how you would then construct your verified. And if you think that your solution is verified, then you would communicate your findings. So you would do your conclusion. Oh, I forgot to put my little red line in. Your conclusion and your summary of what you found and how you found it and what's the importance of it. So that is, also, and in this section here, we use a report. So it has an intro or an introduction, considerations, then you have developing a solution, and the last one is, two last ones, evaluate and verify, and the last one is conclusion. So there are your sections to your report. All of these have been outlined for you in your task sheet. So if we have a look down here, now let's be looking specifically at our task. Designing a garden area to accommodate individual garden beds requires planning and skills associated with measuring such as estimating, measuring and calculating perimeter area and volume. It also requires an analysis of design to prove that it meets the requirements of the task. So your context is designing in a garden area, accommodating individual garden beds and associated with perimeter area and volume, so measuring, calculating and estimating, and also analyzing the design to meet a specific requirement. When you write your introduction, so when you do write your introduction, you want to be putting this in your own words. Now, we'll come back to those in a moment, or in another video. So the task that you've got there is to plan the best garden bed design possible for students to grow their veggies, or produce. So that is what we are looking for. Best possible garden bed for the school. Students can grow something they can all eat, so produce. You're going to try and use your stimulus, that should be that one, not many. You're going to use as much of the resources available to you, develop some formulas for perimeter area and volume of those shapes, and then plan and draw your garden design with the garden beds using appropriate units. So taking in consideration the size of the bed and the pathways in the area. So there are the things that you should be doing in response to making sure that it is a mathematical assignment. And what we're going to look at is the stimulus question that's down here. So it's saying your stimulus question. So these are the things that you really must include. You have to have the design garden area. Ideally, it's going to be the best. And then it has to have a pathway 1 meter wide. Consider the number of shape of beds, so one large and many small, and then addition of water tank. So that is the must-dos. Then you're going to calculate, so you should be, so as our GTEC students or our A-level students, you will be wanting to go from not just must, but should and could. So you should be calculating perimeter area and volume of, the garden area and individual beds and the volume of soil within each garden bed. So that tells you what you need to do. This is essentially you solving a problem. It's a very good jump point for establishing a plan. And then compare your design to design professionally to allow for improvement. So that is what we want to be considering when we do this task. How are you getting through this? How would you write a plan from this kind of information of must, should, and could? What is your context? And how are you going to follow this process of formulate, solve, evaluate, and verify, and communicate to answer your big question of what is the best garden bed can design? So that was a guide to PSMTs. There's another video will be on the other aspects that'll help you complete your PSMT task. Okay, thanks everyone. Stay awesome.